Alright, welcome back to another Roblox game development video. So in this video, this is the third video in the series now. If you haven't checked out the basics tutorial and the advanced basics tutorial, we essentially talked about modeling and also folders as well. Go ahead and go check out those videos. But right now, we're going to go ahead and get into the fundamentals of scripting inside of Roblox. Now, if you'd have no programming experience, that's a-okay. I'm going to go ahead and give you the lowdown on a lot of this stuff. Sometimes this stuff when you first start out can be very overwhelming. So if you feel like you're getting overwhelmed or if it feels really confusing at first, don't worry. We all feel that way when we first start looking at this stuff. It's not really easy to learn, but hopefully I can make it as simple as I can so we can jump right in and get going here. So to start off, let's go ahead and open up a script inside of Roblox Studio. So I'm going to go ahead and grab this part here. To add a script to a part, you'll just click this plus button and click script. And you should have a window just like this pop up on your screen. I'm going to go ahead and zoom in on this window so we can read read all the text here. So let's go ahead and begin by talking about what scripting even is. Scripting is the process of creating instructions for a computer to follow. And just like we have different languages in spoken languages, like Spanish and English, computers also have different languages like JavaScript and Java and Python, and this one is Lua. Lua is what is called an interpretive scripting language, i.e. it's not compiled. So unlike Java and C++, where you have to work inside a compiler, Lua is scripting. And we don't have to really get in the differences between the two. Just know that it is a scripting language. So lines of Lua, or lines of computer instructions, are held in script objects inside of Roblox Studio. There are three different types of scripts, and we'll talk about them in detail later. Just know that there are three main types, and those three types are going to be your server scripts, which are short for script inside of Roblox Studio, your local scripts, which only affect the client. We'll talk about a big distinction between client and server later. And then the last one, and arguably in my opinion, the most important one, the master, is going to be module scripts. And we'll again talk about why module scripts are incredibly important later. But that's essentially the lowdown of the scripts inside of Roblox Studio. Those are the three main ones. Now, before we get started typing anything in these scripts, it's very important to understand a very fundamental principle about programming, because it does relate to many different various programming languages out there, but also specifically Roblox Studio. And that is the idea of a parent-child relationship. This is a very fundamental concept. The idea of a parent-child relationship means that everything either is a parent or a child of something else. So over here, we kind of talked about this earlier, but this is your entire data model, right? Games are just massive amounts of data all compiled together. So if I say the word data model, I'm talking about an entire massive collection of data. And this is your data model for your game. And Roblox Studio even identifies game as your data model here. So everything over here is considered to be part of the game, right? Now, underneath the game, you are going to have various different children. So the service, workspace, player, lighting, material service, all of these are different services and are a child of your game model. To denote or to go between a parent and a child in scripting in Roblox Studio, you're going to use a period. So here, for example, I have the players. I have the game name, for example. I have server storage, replicator storage, all these different children underneath the game model. Okay, so let's go ahead and go over to workspace. So when I access workspace here, I notice that here are all the objects that exist in the workspace. I also have all of these child properties as well. So you have two things. You have the child properties here and the actual physical object children inside the data model here. And again, to access those various children, they're all right here when you click a period, right? So let's say I want to access my obbies folder. I would click dot, and then I can go there and I can grab the model obby1, So that would be this right here. So I'll type in obby1, and then I'll do a dot again, and I can access all the various parts in here. So parts, there's also a primary part of a model, which we'll talk a lot later. You can access part, and then you can even go a step further and access things like the part's color, its can collide, it's anchored, its many attributes, right? But this is the idea of a parent-child relationship. Many different programming languages, HTML is a good one to reference here, have what is known as a parent-child relationship. And essentially it's very similar to what you see here on the screen, which is the idea that everything is either a parent, child, or sibling of something else. So, for example, this part's parent would be this model. This model's parent would be this folder's parent would be the workspace, and the workspace parent would be the game. Everything inside of here is a sibling of each other, and this script is a child of this part. So very important concept there, parent-child. Make sure you understand it, and do not be alarmed if you are typing words like child and parent into your game. Now, with that being said, let's go ahead and talk about the idea of data types. Data types are essentially information that your computer can understand, and you have to use those specific data types in order for your computer to essentially read what you're talking about. Now there are many different data types. If you ever work inside of Java, you'll have to know way more, but for now we're going to start with just 4. These are pretty essential ones and are really good just to know, and I think they're a really good starting point. So let's go ahead and talk about the various different data types. To create a comment inside of Roblox Studio or in Lua, you just do 2 dashes like so. So the first data type we're going to look at is called a string. A string is a sequence of characters encapsulated by quotation marks. So for example, Anthony, this right here would be considered a string in programming. You can also use apostrophes. I don't prefer this myself because if I'm using a contraction like I'm, right, the string kind of breaks, so I like to use quotation marks, but for data storage this might not be the greatest thing in the world. Either way, you can pick whatever you want to use, but that's a string, and a specific one character inside of a string would be considered a char. So a sequence of these is a string. So that's the very first data type that we have to be aware of, and I'll go ahead and put an example here of Anthony. All right, the next data type that we really have to know is going to be an int value. Int value, or int, stands for integer, which are whole numbers and their opposites. So, for example, 7 would be an int value, 10 would be an int value, -11 would be an int value, 27 would be an int value, right? These are all examples of an integer or int value, which are whole numbers and their opposites. Now, something that's really cool about Lua and Roblox Studio in specific is that you don't have to have a ton of data types for numbers. Lua will actually recognize this as a number and will take even non-integer values. For example, 7 point this. And you don't have to denote it as like a long, a short, or anything like that. But the basic data type is an integer that we'll be working with a lot. And the reason why I even bring it up is because if you do an instance new value and you want to create a number, you would need to use int there, as you can see. And that's why I teach integer here. But this will be whole numbers and their opposites. Lua will take numbers though of any type. Just know that int values or the data type int are whole numbers and their opposites. Okay, and I'll go ahead and leave an example here. The next one we're going to look at is the idea of a Boolean. A Boolean is something that can take either the value of true or false. In the vast majority of cases, this is what a Boolean is, but in reality, it's essentially a data type that can only take 2 values, either 0, 1 in binary, true or false, yes or no. It just can take 2 values. That's it. You can't take anything else, right? So, for example, if something could take 0 or 1, it's a Boolean, but if it can take 2, it is no longer a Boolean, right? And in most cases, and in Roblox Studio, it takes the value of true or false. And that's a Boolean. The last one we're going to look at is called nil, or null in other programming languages. In Roblox Studio, this is nil, and on many different other programming languages, this is null. Now, nil means non-existent and is written just like this. Now, something to really keep in mind here is the difference between non-existent and the int value of 0. So, these are not the same thing. And let me go ahead and give you an example, right? Let's say I asked you how much money you have, for example. And let's say, somebody just took all your money and you have no dollars. So your value for money would be 0. Nil is not 0. You would have $0, but you would have nil unicorns, right? Because they're non-existent in the world. There are no unicorns. So the value of unicorn would be nil, but your money would be 0, assuming you had no money. I'm sorry you have no money. That's very, very tough. But that is the general idea behind this, is nil means non-existent. It is not 0. Another good example is Mario. In Mario, you can have 0 coins, but you have nil cell phones. There are no cell phones in Mario, so the value of cell phone, if I typed it into a script, would be nil. But if I asked the value of coins and I had no coins, the computer will respond 0 because it recognizes coins as part of the data model. So that's a very, very important distinction there that I want to make about nil, and make sure that we understand that is not the same as the int/number 0. Okay, so these are the various different data types. As we go through the course, I recommend that you really learn them, really get familiar with them, and really know them. Lua is dynamically typed, so you don't have to declare variables before you assign them, but in future programming languages in your career, you will. And it's really, really good to just know your data types right off the top of your head, because these are just some of the main ones, but they get even more complicated after this. So before we go ahead and type in our first example script, I'd like to talk about the idea of a variable. Now, a variable is a container for a data type. A variable in itself is not a data type. But variables can have types. You'll hear people say this variable type is X, Y, or Z, right? What they mean is the data type that the variable is containing, right? A variable in itself is not the data. So let's look at what I mean by that. Let's say I have local 7. It's been assigned to the int value 7. In this example, 7 is the variable, and the data it contains is the integer or the int value 7, right? And if my computer will recognize this, if I print 7 and I run the game, in my output window here, it will print 7. Right? By the way, if this window isn't up, you always click View and you click the output window here and it'll pop up. Right? So, it's very important to understand that this is the variable, this is the data type. The variable does contain the integer 7, so you could say the variable type, sometimes referred as 7, but variables here are containers. Now, two important things about variables. Variables can vary in value, and they behave as the data they contain. So let's look at what those two things mean. And I'm going to say that again because it's so important. Variables vary in value, and they behave as the data they contain. Super important concept here. So let's look at the first one. Let's say this is a number. Let's say I go ahead and call this local num. We're a game programmer, so I'll call this num of lives is 7. Let's say I now want to change the number of lives. So let's say an event occurred where I got 3 extra lives. Okay? So now I'm going to take number of lives right here, and I'm going to use the addition sign here, and I'm going to add 3. Okay? And I am now going to assign number of lives to this new value. So the number of lives variable now takes on the old number of lives value plus 3. If I now print this value, the number of lives value, it is now 10. And you can see that right here in my output window. So, num of lives changed, right? Because that's a variable. But if I wrote 7 here, right? 7 is a constant. 7 can't change. I can't assign 7 to 8, for example, right? These are constants and data types, right? These cannot be variables. This is the variable which contains this data type, right? So let's make sure we understand it's a very important distinction, the idea of a variable and the idea of a data type, okay? All right, so let's look at the second concept when I talked about variables. Variables will always behave as the data they contain. So let's say this no longer contains the number 7. Let's say this contains now the string 7. When I try and add these together, and I forgot to assign this, right? Num of lives equals 7 of I, right? Right now, my computer is showing no script errors here. So there's no script errors. It thinks everything is fine, right? But when I try and add these things together, it says error. Hold on. You tried to add a string and a number, right? Because I tried to add both a string and a number together, it's not going to work. And that's the idea that the data here changes how this operation behaves. In object-oriented programming, which will be talked about a lot later, OOP in short, but object-oriented, ORIENTED programming, this is the idea of polymorphism, right? We don't have to talk about too much about what this means, but the idea is that this changes, the way this behaves changes based upon the object or data that is contained here, right? Super important concept that variables will always behave as the data they contain, okay? All right, so that is enough talking about all this technical jargon. Let's go ahead and do something cool in the game, and I'm sure you all will relate since you all probably are a huge Squid Game fans. Wow, I said that really weird. All right, so let's say I have a part here, right? I'm gonna go ahead and create a nice little example script here. So let's do it to this part right here. I'm gonna go ahead and create a script here under this part. I'm gonna put the old script over here. So go ahead and look here. In this example, I'm gonna go ahead and create a variable here as part. By the way, if you want things to autofill, you can always use the tab icon. When things pop up on your screen, you can click a period, it autofills. You click tab and it will autofill. So I'm going to set the variable part. This is my variable, and I'm going to assign part's value to the script parent. Let's look here. The script parent is this part in the workspace. So whenever I type in part in my script, it knows I'm talking about this part in the workspace, right? And even if I change the name of the variable, keep in mind variables can be named whatever you want them to be. They just can't start with a number, right? Variables can be named cheese. This could be dog. This could be cat. This could be whatever you want it to be, right? They just can't start with a number, right? So let's say I said this is P. Even if I type in P here, it still recognizes that I am talking about an object part named part in the workspace, which I am because the script is parented to that, right? Now that I've accessed that, I can access all the child properties of that part. For example, the anchor and the can collide. Anchored will make sure the object is immovable by forces, and the can collide will make it collision is on or off. So ID, if this is set to false, I will fall through it. And I know it needs to take a true or false value because it tells me the data type right here that this takes. Right, so now I go ahead and tab this can collide and I will set this to false. And then I can even access the color, for example. This will take a color 3.new, which is a mixture of red, green, and blue. So the first number in this color 3 here will be the amount of red in a color. The second number will be the amount of green and the amount of blue, with 0 representing 0% and 1 representing 100%. And it even autofills in this color wheel here. You can also click the color wheel to go ahead and assign a color, and these values will autofill for you. So let's go ahead and play my game here with this script added, right? Notice that I have this nice little cool looking part over here. My other part from the last game with all that linear velocity stuff is flying. When I go ahead and jump on this, I'm a-okay. But if I jump on this, I will fall right through it because the collision is off. So this is a great example of how you can give your computer a set of instructions to follow. Now notice we went over in the last video all sorts of different child properties, right? Like the name, the size, events. We'll talk more about this later, but like materials, its position, transparency. But here's so many different types of things that you can change, add, and manipulate about a part. And it's all in scripting. And the reason why you would want to do it in scripting and instead of in the properties windows here is because you can use a wait function. A wait function tells the game to wait a specific number of seconds before performing something. So if I tell the game to wait 10 seconds here, I can then change the can collide after what is known as runtime, or after my game is started. But if I'm changing things here all the time, for example, I take can collide off, the moment the game starts, can collide's off. I can't change it, but I can change it in scripting, right? And this is the power of scripting, is you can change things and manipulate the way things behave and work after runtime, where here it's all before runtime. So let's go ahead and look here. When I click home and I click play, notice that I will be able to jump on this block here, but right after 10 seconds, I will indeed fall through it. Give it 10 seconds. There it is. And that is the power of scripting. So go ahead and in your own time, just take some time to look through all the various child properties here and see if you can't find some ways to manipulate them. And if you have any questions, just send us an email or send us a DM and I'll be sure to answer them. And I hope to see you in the next video.